Technology is all around us, which means many of us take it for granted. But have you ever stopped to think, how does it actually work? How does my television produce an image? How does my phone send a message? How does my computer store files? Well, the answer is simple. Number systems. You may be wondering, what's a number system? Well, I'll tell you. In its basic form, a number system is code that represents stored information in a computer. However, computers don't understand English. It'd be like someone who only speaks English trying to communicate with someone who only speaks French. So, we must use number systems in order to relay information in a way the computer can understand. For a computer, their equivalent of English is number systems. There are four main number systems: hexadecimal, octal, decimal, and binary, with binary being the most basic. Essentially, all digital computers are made up of zeros and ones, binary. Remember how I said a number system is code? Well, think of the number system as English, the code is words, and the zeros and ones as letters. We need multiple words in order to make a comprehensible sentence. Binary code is a series of electrical impulses. Think of these pulses as the process of writing. In binary, each 0 represents off, and each 1 represents on. So think of it like, as you are writing, you are deciding which letter to write. This is the pulse. Then, going through each letter, you'll either decide to write it, which is the 1, or not, which is the 0. Then, at the end, you'll have a code that translates into information. You may be thinking, if binary is the basic number system, why do we have 3 others? Well, each number system is responsible for different actions and information in a computer. That means it is important for these systems to communicate to each other. How do they do this? Conversion. Like earlier, think of it like someone who speaks English trying to have a conversation with someone who speaks French. In this case, conversion would be the translator between the two. Now, how do I convert between number systems? Well, there is one method with slight variation between the number systems for converting to decimal, which I don't actually know if it has a name. So I'll just call it the addition method for the sake of this video. Then there are 2 methods when converting from decimal, called subtraction and division. Luckily, the process of converting between number systems is similar no matter which system you are converting. However, the factorial numbers vary depending on the system you are converting to. There is only one exception to this process, and that's converting from octal to hexadecimal and vice versa. For these conversions, you must first convert to binary, but I will show you this later on. Before I begin, I'd like to explain another important difference between all of these number systems. Each system has its own unique base. Binary has a base of 2, decimal has a base of 10, octal has a base of 8, and hexadecimal has a base of 16. What does this mean? It means that each system can only be represented by that many numbers, but not just any numbers. Binary's numbers are 0 and 1, decimal's numbers are 0 to 9, octal's numbers are 0 to 7, and hexadecimal's numbers are, well, a little weird to be honest. It's 0 to 9 and then A to F, as in the letters. A to F represents the numbers 10 to 15. I don't know why they don't just write 10 to 15, but it's computers, so it's gotta be a little complicated and confusing. Now, on to converting using the addition method. Now, no matter which number system you're converting from, it's best to make a table with the base number at the top, starting with the power 0, and go up a power as you move towards the left. Then, make a row under it with the product of each power. We're starting with converting from binary, which has a base of 2. So our table will look like this. Now, binary is the simplest to convert from. Make another row at the bottom of your table. All you have to do is write the binary number underneath, with each number corresponding to a column. The number we will be using is 110101. All that's left is add up the numbers with a 1 underneath. Then that's it. Your decimal number is 53, base 10. Now, let's try another example. Can you tell me what the decimal number is for 101101? I'll wait about 3 seconds and then tell you the answer, so you might want to pause. Okay, so here's my table setup. I've put my binary number at the bottom, and now all I'm going to do is add up the numbers that have a 1 underneath. So my answer is 45. Now we're going to convert from octal to decimal. As I said before, start with making a table of your bases with powers from 0 to the number of digits in the number you're converting from. Remember, octal has a base of 8, so our table will look like this. Then, as you did for binary, write out the number underneath, making sure the last digit is in the far right column. In this example, we are using the number 1246. Then, multiply the numbers in the bottom two rows, column by column. Like this. 6 times 1 is 6, 8 times 4 is 32, and so on and so forth. Then, add up the products of each column you multiplied. Our decimal number is 678. Remember to write the small 10 on the right. Each of these smaller numbers indicate which number system the number is in. Now, I'm going to get you to do this on your own. What is 236 octal in decimal? Alright, just like the last one, here's my table. I've put our number 236 at the bottom. Now I'm going to multiply 6 times 1, 3 times 8, and 2 times 64 and add them all together. So my answer is 158. To convert from hexadecimal to decimal, the process is very similar to converting from octal. The only difference is you must change the base number to 16. With this in mind, can you convert this hexadecimal number to decimal? Remember, hexadecimal is a little different. Once the number equals 10, you must replace it with the alphabet and vice versa. A is 10, B is 11, and so on and so forth, up to and including F. Feel free to pause the video. Okay, let's see how you did. If you did it correctly, you should have gotten 500. Now, let me walk you through the process. First, I'm going to write out my table. Then, I'm going to align the number I'm converting from with my table, which looks like this. Now, I'm going to multiply the bottom two rows. 1 times 4 is 4. F is the number 15, so 15 times 16 is 240, and 256 times 1 is 256. Added together, that's 500, which is our answer. Okay, now we're all done with converting to decimal, but how do we convert from decimal? This is where the subtraction and division methods come in. Let's start with decimal to binary, using the subtraction method. For this, we're going to refer back to our powers chart. Take the number you're converting from, then subtract out the largest power of 2 possible without going below 0. Since this is binary, we are using the base 2. In this example, we are using the number 56. You can see I crossed out 2 to the power of 6 because 64 doesn't fit into 56. Then subtract the largest power of 2 you can from that number without going below 0. Continue this until you reach 0. Then, in your chart, place a 1 under every number you subtracted, and a 0 under the ones you didn't. The number you create from the zeros and ones is your binary number. Now, let's do decimal to octal using the subtraction method. Luckily, the process is very similar, except for octal, instead of writing zeros and ones, we are going to write the number of times we were able to subtract out the largest power of 8. So for the number 2018, we can subtract 512 3 times, 64 7 times, 8 4 times, and 1 twice. Collect the numbers and there's your answer, 3,742. And lastly, hexadecimal is very similar, just changing the base number to 16. Here is the number 810. Can you find the hexadecimal conversion? Alright, so hopefully you should have gotten the answer 32A. If not, here's how I did it. I have my table with the powers of 16. Then I subtracted the largest multiple I could out of each column. I can subtract 256 3 times from 810, 16 2 times from 42, and 1 10 times from 10. Collecting the numbers in order and remembering that 10 is A, I have the answer 32A. Moving on to the division method, make a table like this one. For decimal to binary, keep dividing by 2, making sure you don't go below 0. Once you go below 0, stop. If you divide by 2 and there is no remainder, put a 0 in the remainders column. If there is a remainder, put a 1. Once you're finished, collect the remainders from the bottom up, and there's your binary number. Easy, right? And guess what? Octal and hexadecimal are similar, except you replace the base number with the corresponding number system and write the actual remainder instead of zeros and ones as well. Knowing this, what is the octal conversion for 4,330? Well, let's look at our table. 4,330 has a remainder of 2, 541 has a remainder of 5, 67 has a remainder of 3, 8 has no remainders, and 1 has a remainder of 1. We must stop here because we've hit 0. Now, collecting from bottom up, the octal number is 10352. Here's another question. Which is the hexadecimal number for the decimal number 126? Be sure to use division method. That's right, the answer is 7E. Here's the table if you'd like to take a closer look. That's all in terms of methods, but what if you want to go between octal and binary, or hexadecimal and binary? Well, those are easy. Here's a chart representing each binary value for every octal value. To convert between the two, literally just replace the corresponding binary value with the octal value and vice versa. However, note that all binary values are in 3 bits. That means when going from binary to octal, you must start at the far right and group every 3 digits. What if the number of digits isn't divisible by 3? Add 1 or 2 zeros at the beginning, depending on whether it is 1 or 2 numbers left over. Like if it's 10000001, you would add 00 to make it 3-bit. So what is the octal value of 101000110? That's right, it's 246. Hexadecimal is similar, except it's 4 bits instead of 3. And the adding 0 rule applies here too, if the number of digits is not divisible by 4. So, which of these is the correct conversion for 3D9? Correct! It's 001111011001. There is one exception when it comes to conversions though, and that is you cannot directly convert between octal and hexadecimal. I mentioned this at the beginning, but you must first convert one to binary, and then from binary to the other. Alright, the last thing I'm going to talk about is ASCII. ASCII stands for the American Standard Code for Information Interchange. What does that mean? Basically, it's a fancy chart of 128 characters in the English language. All you need to know is that each character has a binary, decimal, hexadecimal, and octal value associated with it. And the conversion between each is the exact same that I've been going on about for the past 10 minutes. So, I hope by now you know what coding is, what a number system is, how to convert between number systems, the exceptions, and a little bit about ASCII. If you managed to pay attention to everything I said and understand it, then good job! I'm actually quite amazed, because honestly, I have no idea what I was saying 5 minutes ago. And, if you're watching this to help you pass an assignment, then, good luck, bud. Also, if it was really helpful, you should totally share this with your teacher. They might even give you bonus marks. Anyways, bye!